Recall that the symbol mu represents micro, which is 10 to the negative 6. So let's go ahead and use the calculator for some of these problems. We're going to calculate the magnitude of the force. This means don't worry about the positives or negative as for the sign of the answer. We're going to calculate the force between two electrons that are 1 millimeter apart. Here's the K, the constant. We have two electrons, so this is going to be negative 1.6 times 10 to the negative 19 coulombs. There's one electron, and then the other electron has negative 1.6 times 10 to the negative 19 coulombs. Sorry about that. And then the denominator is going to be 1 millimeter apart. That's 1 times 10 to the negative 3 meters. Why? Because it's millimeters. You're going to want to go back and review some of your prefixes from our first set of notes ever in this class. Notice that we have 1 meter here. Actually, forgot the squared. So notice that we have meter squared. Those cancel out. And we have a Coulomb squared with a Coulomb times a Coulomb. So we're left with the correct unit for force, which is Newton. We're going to type this into the calculator. Parentheses are pivotal in this case. Make sure in your calculator that you're using the negative and not the minus. Each calculator will have a different scientific notation capability. In most calculators, especially TIs, they have this, you push the second and you push a button where it says E. You can see a capital E. Okay, that's going to be your 10 to the power. So for example, you see how I have 9E9? That's 9 times 10 to the 9th power. Okay. I'm going to do negative 19. Negative 1.6 times 10 to the negative 19. Close parenthesis for the numerator. Start the denominator. It's going to be 1 e to the negative 3. And that's going to be squared. And for that we get 2.304 times 10 to the negative 22 newtons. So your calculator will have an E or some funny letter like that, or a negative 22. Remember, that means 10 to the negative 22 power. Okay, this is a very tiny force. For this next problem, we have a charge of positive 1.5 nanocoulombs, a negative 2.0 nanocoulombs, and we have a distance separation of that. Find the electric force between the two. So recall K again is 9 times 10 to the 9. We have the charges 1.5, positive 1.5 times 10 to the negative 9 coulombs, and then negative 2.0 times 10 to the negative 9 coulombs, all over 1.5 times 10 to the negative 2 meters squared. Don't forget that square I did earlier on accident, or maybe not, just to kind of make a point. Most students will forget that squared. Please be careful with that squared. Again, notice that the meter squares are going to cancel out. The Coulomb squares with its 2 coulombs. I'm left with the correct unit of newtons. We'll type into the calculator again. I have double sets of parentheses because I want to make sure the whole numerator is in its own set of parentheses. You may or may not need to put up times between each of these, depending on your calculator. Don't forget, a negative is different than a minus sign, so make sure you're doing the right one. Do not be typing these in with times 10 to the negative, times 10. You're going to confuse the calculator, confuse yourself. Make sure that you become familiar with your calculator's capabilities and how it deals with some of these things. So I have double checked these answers in this calculator, which I'm showing you, and another calculator that's more commonly used. just to make sure that these are coming out right, I would strongly suggest to you that you please figure out, try to get the same answers as I'm getting here, but with your calculator. Okay. Now in this case, I'm getting a negative 1.2 times 10 to the negative 4 newtons. In this problem, it did not say the word magnitude. So you need to have the sign. And what this negative sign is telling us is that this is an attractive force. And this should be pretty obvious because you have one positive charge and one negative charge. You have opposites that are attracting. You may have also gotten the answer negative 0.00012, which you would have to go ahead and then make it into scientific notation. So you'd move this row 1, 2, 3, 4 spots, and that's how we get the negative 1.2 times 10 to the negative 4 newtons. Okay, so just be aware of that. Be aware of that. Now we want the magnitude of the electric force between two So they gave us the magnitude of the electric force. They gave us the force. Notice this is in newtons. How far apart are they? So recall we have Fe is equal to KQ1 Q2 over R squared. We want to get the R squared by itself. Some of you still struggle with this algebra task. We've done it multiple times in this class. So if we end up cross multiplying, it essentially ends up just switching places. And I want R by itself. So I square root the whole thing. Square root the whole thing. So in this case, R is KQ1 Q2 over R squared. Make sure the entire thing is being square rooted. So if we plug everything into this equation that we just derived, you're thinking, where did everything come from? Well, of course, we have this value is a constant. That's K. But then they told us these are protons, and I think I just made a mistake. These shouldn't be negatives, should be positives. These should be protons. The proton has the same charge as an electron, except it's a different sign. So in this case, protons would have a 1.6 times 10 to the negative 19 Coulomb charge. There's two of them, so I have two of them right there. And then don't forget the force underneath. We keep tabs of all these units, right? The newtons, Coulomb squared, Coulomb. I left with a meter squared. Okay, so if I square root a meter squared, I get a meter. So the calculator gives a 0.03794, etc. I rounded it up. And of course, note that this is a very small number, so we might consider 1, 2, right? We could say this is 3.79 centimeters. We could even go, let's try a different. 1, 2, 3, we can see this is 37.9 millimeters. So be aware that when it comes to this kind of stuff, we have to be a bit more fluid and flexible with how we express our answers. Okay? For your summary, be sure to know how to get the same results from your calculator. You have to be very comfortable with your calculator. Please.